the angle subtended at the center is double the angle subtended at any point on the remaining part of the circumference for any arc of the circle. So let us discuss few scenarios. Let us first of all take this as the arc. Okay, let it be arc AB, and this is center O. Okay, and join this with these points A and B. So this is the angle subtended by arc AB at the center, and let this be any other point on the circumference, on the remaining part of the circumference, and this is the angle subtended at the circumference of the remaining part of the circle. Now we need to see that this angle here, angle subtended at the center, is double this angle. Okay, so what I do here is I'll join these 2 points and extend this line like this. Okay, and now look at this. If this is O and let it be M, what can I say about OM and OA? OM is equal to OA, right? Because these are radii of the same circle. So this angle, if this angle is, let us say, alpha, then this will be equal to this angle, right? Base angles of an isosceles triangle. This triangle is an isosceles triangle with these sides being equal. So the angles opposite to these equal sides will be equal. So if it is alpha, then this will also be alpha. With the similar logic, you can say if this is beta, then this angle will be beta, because this is another isosceles triangle with OB equal to OM, right? Now look at this triangle AOM, triangle AOM. For triangle AOM, this angle here, let us name it as angle 1. This angle, angle 1, is an exterior angle to this triangle. So angle 1 will be equal to sum of opposite interior angles. So it will be equal to alpha plus alpha, that is equal to 2 alpha. Similarly, if this is angle 2, it will be equal to beta plus beta, right? Because this angle is an exterior angle to this triangle BOM. So angle 2 is twice of beta. And if I collectively look at this angle, this is an angle subtended at the center. So angle 1 plus angle 2 is nothing but twice of alpha plus twice of beta, that is twice of alpha plus beta. And what is alpha plus beta? Alpha plus beta is an angle subtended at the circumference of remaining part of the circle. That is, if I want to say that this angle here, which is angle 1 plus angle 2, angle 1 plus angle 2 is double of this angle here, which is alpha plus beta. And I have just proved it using the fact that base angles of an isosceles triangle are equal, and exterior angle of a triangle, let us say this is an exterior angle, is equal to the sum of opposite interior angles. That is, if this angle is angle 1 and this is alpha and this is, let us say, beta, so angle 1 will be equal to alpha plus beta. But this was a case of isosceles triangle. So if this is alpha and this is alpha, because of this being an isosceles triangle, then 1 will be equal to twice of alpha, right? This is what I used here while proving this. So another scenario, let us take one more scenario, or rather 2 more scenarios. Let us say this is the circle in question, and this time this is the arc, and this is an angle subtended at the circumference, and let this be the center. So if I join these, right, this is A, this is B, and let this be C. If I join these O and C and look at this angle here, look at this angle. Okay, let me join this also. Now see, if this is alpha, what will be this angle here? This will also be alpha. Why? Because OC and OB are the radii of same circle, which makes this triangle isosceles. So base angles are equal, or angles opposite equal sides are equal. Similarly, I can say if this is beta, then this angle here, this will also be beta. Now this, let us say this is angle 2. This being an exterior angle of this triangle, OBC, OBC will be equal to alpha plus alpha. So angle 2 is equal to alpha plus alpha. I am following the same logic, in fact, that I used for this arc, right? For the above arc that I just proved. And if this is angle 1, this will be equal to beta plus beta, because it is an exterior angle. So it will be equal to sum of interior opposite angles. So it will be equal to twice of beta. And if I collectively look at this angle, right, this is angle 1 plus angle 2, and it is twice of alpha plus beta, which is nothing but this angle at the circumference. So again I proved the theorem that angle subtended at the center by any arc is double of the angle subtended by the same arc at the rest of the circle, any point on the circumference of remaining part of the circle. Let us take the arc to be like this. Let this be the center and this be the arc that we are talking about, right? This is center, and let us take any point here on the circumference. Now we will look at this angle and this angle. Okay, so let me join this with the center. Okay, and let it be AB, and I'll join A and B. Okay, now if this point is C, OC will be equal to OB, because these are radii of the same circle. So what can I say about this angle and this angle? That these are equal. So if this is beta, then this will also be beta. Another thing, that if this OC is a radius, OA will also be the radius, right? So if this angle, let us say, is alpha, then what will be this angle here? This will also be alpha, because of the reason that I just told you, that opposite angles of equal sides. Now the angle in question, that is this angle here, what will be this angle? This will be beta minus alpha, right? And this angle here, let us first of all talk about this angle. This is an angle which is exterior angle for this triangle BOC, right? For triangle BOC, this will be an exterior angle. So it will be equal to beta plus beta, sum of interior opposite angles. So this angle here is twice of beta, right? And if I look at this angle, let me change the color so that you can understand clearly. If I look at this angle, this will be an exterior angle for this triangle OAC. This angle is an exterior angle for triangle OAC. Hence it will be equal to alpha plus alpha, alpha plus alpha, 2 alpha. So the angle in question, that is the angle subtended at the center, this angle will be difference of this, that is 2 beta and 2 alpha. So it will be equal to 2 beta minus 2 alpha, this angle, right? Angle subtended at the center. And what will be this angle? Angle subtended at the circumference. This will be difference of beta and alpha, that is beta minus alpha. So you can see that the angle subtended at the center is twice of beta minus alpha, right? And what is beta minus alpha? It is the angle subtended at the circumference on the remaining part of the circle. So again, this theorem is proved for this diagram also, this scenario also. All right, I hope this theorem is clear to you.